So today we're going to be talking about the difference between linear versus nonlinear. Linear is going to mean that it's a straight line. It could be horizontal, vertical, or diagonal. And linear also is going to have a constant rate. So that means that the values go up by the same amount in the x's, and then they also go up in the same or down the same amount in the y's. Every time you see a linear equation, it's going to either be in y equals mx plus b, or in standard form. This is actually slope-intercept form, where this is standard form, which is ax plus by equals c. Now, sometimes you'll see a linear equation where it's not necessarily in these forms, but you can get it into y equals mx plus b. Those examples are still going to be linear. Nonlinear means that it's not going to be a straight line. So you'll see like a U-shaped graph, which is a quadratic equation. You might see a V-shaped graph, which would be an absolute value equation. Those are all examples of something that is nonlinear. It's not going to have a constant rate, so it's not going to be going up by the same amount. And then it's not going to be in y equals mx plus b. You're also going to notice with nonlinear functions is that it's going to have exponents and it's also going to have square roots. So the examples on the left are going to be examples of linear functions, where the examples on the right are going to be examples of nonlinear functions. So if you notice with this one, it's in y equals, your m is your slope, which is 2 plus 10, which is going to be your y-intercept, okay? Another example of this would be y equals 7. This type of equation, even though it doesn't have a slope, it makes a line that's like this, which is a horizontal line, and it actually has a slope of 0. So this would be an example of a linear equation because it is a straight line. Now with this one, you're going to notice you do see an exponent, but it's not next to the variable. So that still means that it could be a linear equation, because 3 to the third power means that it's 3 times 3 times 3. Okay. 3 times 3 is 9. 9 times 3 is 27. So technically this equation is 27 plus 7x, which is a linear equation. So I would mark this one, if I saw this as an example, as a linear equation, because 7 is my slope and 27 is my y-intercept. Now, this is an example of a linear equation as well, because of the fact that it's in standard form, and I can actually get this into, which we did earlier this year, I can get this into y equals mx plus b, which would be 6y equals negative 4x plus 12. Divide by 6 because I want to get y by itself. And my equation is going to be negative, it's actually going to be negative 2/3 x plus 2. So it does get put into y equals mx plus b. So that would be a linear equation. Now, these three examples right here are examples of something that would be nonlinear. If you notice, it's y equals 2x squared. The exponent is with the variable, so that means plus 2. This is actually what's called a quadratic function, you'll notice, but it's nonlinear. A quadratic function is going to be more of like a graph that looks like this. So this is a nonlinear equation due to the fact that it is a U-shaped graph. This one is going to be a nonlinear function due to the fact that it's to the third power. This is the graph that some of you might have saw where it looks like an S shape. That is going to be a cubic function. So even though it is a function, it's non-linear because it's not a straight line. And then y equals the square root of x. This function looks something like this. So it's going to look like this going that way. And this is an example of where it's not actually a straight line. It has a little bit of a curve to it. And that would mean that's a square root. So these would be examples of something that is non-linear.